So now we want to talk a little bit, and eventually we'll talk more in depth about this. So we're just going to kind of start off slow. We'll build into it, and hopefully at some point we'll stop and spend the whole day on this. But for now, we want to revisit average velocity. Okay, this is going to build into our study of velocity and position of objects in free fall, and that just means that they're not launched at an angle. They're either thrown straight up, straight down, or dropped. Average velocity is sometimes given by this notation, a little v with a line across the top. And all you do to find average velocity is find the change in position over the change in time. Average velocity has nothing to do with calculus. It is simply an algebraic concept that you are continuing to miss. So we're going to go back over it, okay? Now, there are different notations for this. Basically, this book that we're going to be using uses position function as s. Okay, so it'll use the position function as s. That's why it'll say change in position, so change in s over change in time. This is the same as the average rate of change over an interval where the x's are the times and the y's are the heights off the ground. Okay? And so how do you find the average rate of change of anything? You write two ordered pairs and do what? And do the slope formula. And you just find the slope between them. That's how you find any average rate of change. So you write your two ordered pairs and you find the slope between them. So for average velocity, those two ordered pairs are going to consist of two times for your x's and two heights or positions for your y's. Those would be your s's. So they're actually t's and s's rather than x's and y's. So here's our last problem of the day. A ball is dropped from 100 feet and it has a height s at a given time t, and it's given by the position function s of t equals negative 16t squared plus 100, where s is in feet and t is in seconds. We would like to find the average velocities of that ball over the following intervals of time. Now I've written these as intervals, okay, but basically all I'm saying is that I want you to find the average velocity of the ball between 1 and 2 seconds, between 1 and 1.5 seconds, and between 1 and 1.1 seconds. So in order to do that, we have to write two ordered pairs. So these are our t's. These are our times, our intervals, okay? We know the function is s of t equals negative 16t squared plus 100. So if I want to write two ordered pairs, I have 1 comma something and 2 comma something. And we have to substitute into the position function to find those other numbers there, to find the height. So after 1 second, how high up is the ball? 84 feet. After 2 seconds, how high up is the ball?
36.
36? Okay. And to find average velocity, you simply do the change in position, so the change in the s's, that's the 84 and 36, over the change in the time, which is the same as the slope. So you say 36 minus 84 feet over 2 minus 1 seconds. And that equals? 48 over 1? So 48 feet per second. That's how you find the average velocity. It's negative though, right? Velocity is a signed number, so we have to leave it there. Speed isn't, but this is velocity. So it's negative 48 feet per second because it's falling towards the ground. So I'm going to pause right there and let you calculate the other two, and then we'll talk through them. All right, for the second interval, my first time is 1. What's my first height? Still 84. My second time is 1.5. What's that height? 64. Can somebody verify?
Yes.
Yes? Okay, perfect. So the average velocity is 64 feet minus 84 feet over 1.5 minus 1, which is just 0.5 seconds. What does that calculate to? Negative 40 feet per second. All right. And for the final one, for average velocity, we have the interval from 1 second to 1.1 seconds. So they're very close together in time. So we have 1 comma 84. And what is 1.1's height?
80.64.
80 point what?
64.
64. So we calculate the average velocity by taking 80.64 minus 84 feet and dividing it by 1.1 minus 1, or 0.1 seconds. And what does that equal? Negative 33.6 feet per second. Can we verify?
Yeah. Correct.
Yes? Okay. All right, so let's stop there for the day, and we'll look at this versus instantaneous velocity at the beginning of class next time.